Yeah. Okay, guys, so let's start. So, as I told you, I'm going to give a lecture, okay, until 5:45, 5:50. After that, I'm going to give you 10, 15 minutes break, and then we're going to start the test 6 o'clock, okay? So, I want to continue what I started last time. So, last time I was here in this program. Okay, so I told you in this program we want to do something like serial communication. So you are going to send some data serial, and as I told you, just give me just 1 second. I'm not sure I'm not able to maximize it. Okay, so just want to hide this one. So okay. Okay, so as I told you guys last time, serial communication means where this is the microcontroller. Okay, this is the microcontroller. We have one pin here, one pin. Okay, so if you connect the scope to this pin, you can see the data serial. Okay, serial means every certain time, like 10 millisecond, 5 millisecond, whatever it is, you are going to get 1 bit, right? So if you connect the scope here, and that's what you should do in next lab, you should see something like that. This is serial data. So here you can see for some time it is 0. This time can be whatever, 10 millisecond, 5 millisecond, whatever. Okay, and then here it's 1, and then 0, another 0, and so on. Right? And I told you here, I'm going to repeat. So after this is the information I want to produce. It is 0, 1, 0, 0, 1, 1, 1, 1. And then I told you, if you do it only one time, you look at the scope, you're not going to see anything because it's very quick, okay? So that's why I told you in order to be able to see it on the scope, repeat it, okay? But in practical application, you don't need to do that. This is just to be able to see. That's why you can see here it is repeated. So 0, 1, 0, 0, 1, 1, 1, and then it is repeated here. I'm repeating it here. Anyway, so last time I explained how can you do something like that in assembly, right? And then I'm going to repeat it again quickly, and then I'm going to explain how can you do it in C. So the way we're going to do it in assembly, we're going to have, so we have a byte. So your information is this byte. The name of this variable is P, as you see here. Okay, so we have a byte. The information is here, 0, 1, 0, 0, 1, 1, 1. Oh, sorry, I think 3 ones. Anyway, and then what I'm going to do very easy. Look, I'm going to shift. When I shift, I'm going to take this bit in the carry. And then I'm going to check if the carry is 0. So I'm going to output 0. If the carry is 1, I'm going to output 1. That's it. Very simple, right? I already taught instruction before. How can you check if the carry 1 or 0? Also, I already taught instruction before. If you have a pin, okay, which this pin, as you will see right now, this pin, which is BT0, right? So this pin is actually, it is just 1 bit in a byte. Okay? This byte is port H. Port T, PTT. Okay, so if you have a byte, how can you set or how can you clear one bit? I already explained it multiple times. Okay. Okay. I'm gonna finish this program and then I'm gonna take your question. Just give me one second. Okay. So and then this is how it is. So I'm gonna shift. So I'm gonna do a loop. In this loop, in every iteration, I'm gonna shift to take one bit, and then I'm gonna check this bit, and then I'm gonna output 1 or 0. Is that okay? One more thing I'm gonna do is every time I shift this bit, you know, as I explained before, when you shift with 0, right? So what I'm gonna do, I'm gonna copy this bit back here. Okay, why I do that? So that after 8 shifts, I'm gonna get the number again and repeat. You got what I'm saying? And that's what I did here. So if you look here, this is the loop we started from here. Okay, the first part here, as I said before you use any port, you have to configure this port, output or input. In this case, we have only one pin, PT0, right? So I have to configure this one output, right? That's why I'm gonna do this one. Okay, you have to do this one. So this is just initialization, but most of the time your program is gonna be here in this part, most of the time. So as you see here, first I'm gonna shift, as I told you, shift left, right? Then I'm gonna check the carry branch if carry is set. So if the carry is set 1, if the carry is storing 1, I'm gonna go to here to high. Here in high, I'm gonna output 1 bit set BTT 01 to output 1 in BT0. Okay, and then you are gonna put 1 in P, as I told you, in the variable P. If the carry is 1, I have to write back here. Okay, so that's what I did here. Is that okay? After that, you can put some delay here. You can make some delay, as I explained before, 5 milliseconds, 6 milliseconds, whatever. Okay, because you want to keep you output 0, 0 or 1, right? Again, as I told you before, 0 or 1. This is in logic, right? But in voltage, as you will see next slide, 0 or 1 are actually 0 volt or 5 volt, right? So you want to keep this 5 volt or 0 volt for some time, and that's what you can see here. So what you can see here, I keep it for some time. Okay, I keep this one for some time. So you have to put here a delay. Okay, you can make a delay 5 milliseconds, 10 milliseconds, whatever. Okay. Now, if the carry is 0, so the loop, I'm not gonna branch it to here. I'm gonna continue here. So what should I do if the carry is 0? Number 1, instead of using bit set, I'm gonna use bit clear because I have to output 0, right? Because the bit is 0. And also, I can copy 0 here. Okay. Anyway, that's what I explained in the lecture. And I told you, I may not even need this instruction. Okay. Because if the carry is 0, when you shift, you already shift with 0. So you don't need to write 0 because it's already 0. You got what I'm saying? Anyway, yes. What's your question?
It was just about how you had the PT0, you're missing the 1 on the end. That was just all I was going to say. It's already erased, but
Okay.
it was just you wrote out 0,
okay.
1, 0,
okay.
0, 0,
yeah,
1,
yeah.
1, 1.
Yeah. Sorry. Yeah. I put 3 once, it should be 4. Okay. Thank you. Okay, guys. So this is how in assembly. In C, you can do the same thing. In C, you can use the same programming instruction, or the same way you can do it in C. However, in order to learn better, I'm going to use another approach because I want you to learn several ways. Okay, so I'm going to do the same thing, but using a different way in C. That doesn't mean I cannot do the same thing in C. No, you can, but I want to teach you different ways. Okay, so here in C, this is the program I'm going to do in C. How this program is different. So in this program, I have a byte. This byte, I call it pattern. Instead of P, I call it pattern. Okay. And then I'm not going to shift this pattern. Okay. What I'm going to do, I'm going to have another one. I'm going to call it mask. Okay. Okay. So here, I'm gonna have another one. We call it mask. This mask I start from 80, which is 1 0 0 0 0 0 0. Is that okay? So and then as I explained before, how can you check if this bit is 1 or 0? How can you do it? Okay. As I explained before, so I want to check this bit, right? If it is 1 or 0, if it is 1, I'm gonna output 1. If it is 0, I'm gonna output 0, right? So I want to check this bit. How can you check it? As I explained in the lecture several times in assembly, also in last lecture in C. What you have to do AND operation, and then so the result here, so this is bit 7. So the result here is gonna be bit 7 and then 0 0 0 0 0 0. Okay. I need to count how many zeros. Okay. 1 2 3 4. Okay. 1 2 3. Yeah, it's okay. So now, and then I'm gonna check what is this value. If this value is 0, that means bit 7 is 0. Otherwise, bit 7 is 1. Is that okay? So this is for one iteration. Next iteration, I'm gonna shift the mask. So next time, mask is 0 1 0 0. Is that okay? This is in the second iteration, because in second iteration, I have to work on this bit. I have to work on bit 6, right? So in every iteration, I'm gonna shift it one time. Okay. Next iteration, I'm gonna shift. So I'm gonna put the 1 here and zeros everywhere, right? So that I want to check this bit. I want to check bit number 5. So I'm gonna continue this way until the 1 comes to here, right? And then when I shift it, now mask is equal to 0. So once the mask is equal to 0, I have to return the 1 back so that I repeat. Okay. So once I shift this 1, okay. So now I have to return it back so that I can repeat again. So it's just a different idea, but let me tell you how it works. So number 1, before you use BT5, BT0, you have to configure this pin as output, right? And the way you have to do it here, data direction register for port T, right? And here I use OR operation, so that this is the data direction register for port T, so that I want to put 1 here. When you put 1 here, using OR operation, I actually configure BT0 as out. Is that okay? Anyway, and now, so this is just the configuration. Again, guys, in this chapter, all the time we're going to do that. For any port you have to configure it first, input or output, right? This should be done only one time. You don't need to repeat. Just one time is enough, okay? And even I explained in one lecture what this configuration should do, right? So this configuration should connect the hardware so that the circuit becomes input or out, right? That's why you have to do it at least once, right? In the beginning, not at least, it should be 1. There is no need to keep, but if you keep repeating, it's not a big deal, but you shouldn't. Okay, there is no need to do that. And then the program is going to be here all the time. So I have infinite loop. So all the time I'm going to be here. Okay. So as you see here, guys, first mask is 80, which is 1 0 0 0 0 0 0. And then I'm going to do AND operation. As I told you, I'm going to do AND operation. And now, if I do AND operation and the result is 0, what it means? It means bit 7 is 0. The bit I'm checking right now is 0. Okay? In the first iteration, it's bit 7. Next iteration, because I'm going to shift mask, is going to be bit 6, bit 5, and so on. Okay? So the bit I'm checking right now is 0 if it is equal to 0. So if it is 0, what should I do if it is 0? I have to output 0. How can you output 0? Also, as I explained in the lecture, you have to use AND operation. So here, BTT should equal BTT and this value. Is that okay? To output 0, AND operation. Again, as I explained before, for every port, we're going to work in 2 registers. One is called data direction register, T, and this is the one I used here. This one is used to configure or to program the port input or out, right? Second one we're gonna use is the data register. This data register is actually, if you read data from the port, you have to read it from this register. If you write data to the port, you have to write to this register, and that's what I did here. And this one you can use it multiple times. Always use it multiple times, that's okay, right? Because this is the port itself. So anyway, as you see here, I'm using BTG. This is the port. I'm gonna output 0 here. Is that okay? Once you put 0 here, so the corresponding, as I explained before, so this is PTG, right? So once I put 0 here, the corresponding bit becomes 0 volt. Once you put 1 here in this register, you are gonna make here 5 volt. Is that okay? Anyway, so here I'm gonna output 0. So BT0 is equal to 0 using AND operation. Now, else. Now, if the result is not 0, what it means? It means BT0 has to be 1. That's what I did here. So here I'm gonna output 1 using OR operation. I explained again many times how can you use OR operation to set some bits and don't change the other bits. How can you use AND operation to clear some bits and also don't change the other bits? Okay, if you don't know this one, check the lectures before. Anyway, so now this is if statement here. Okay, now what should I do after that? I already output 0 or 1. What should I do? Number one, I have to wait for some time. Okay, that's what I did here. So I'm gonna wait 10 milliseconds. After that, I'm gonna shift the mask to the right, as I told you. So I'm gonna shift the mask to the right. Why? Because in the first iteration, it is like that. In next iteration, it will be here. Okay, in next iteration, it will be here, right? All the way until 0, 0, 0, 0, 0, 0, and then 1, right? So every iteration I have to check one bit, and then based on the value of this bit, I'm gonna output 0 or 1. Is that okay? Again, and then in the last iteration, if you already did this one, when you shift, I'm gonna get 0, right? When you shift, that's what I'm doing here. So now, first I'm gonna shift. So here 1 means it's one time, one shift, right? So here you shift, and then if it is equal to 0, so now I have to return the 1 back because I'm gonna repeat, right? For repeat it. Okay, guys, any questions? If you have any question, raise your hand, okay? Again, I told you, it's not a problem, but this is the problem of this course, okay? The problem is, every lecture I have to use the information I taught in previous lecture. This is how this course is. You got what I'm saying? I try to repeat, okay? But I'm not gonna keep repeating this way because I have a lot of material to finish, okay? For example, how can you use AND operation to clear some bits? I already explained it before. If you don't know it, maybe you are gonna be confused now, okay? Same thing for OR and so on. Any question, guys? Okay. Coming lab, okay? In the coming lab, as I told you in the lecture, I made it easy because this is the first lab you have to use the board, okay? So in the coming lab, it's just number one, it's gonna be a little modification to this lab, to this one here, yeah, to this program, little modification. But I'm gonna ask you to generate different square waves, something like that. So all what you have to do, just you can play in the amount of the delay to generate different square waves. Okay. The coming lab needs a scope, okay, to connect it to the pins to see the signal by yourself, right? So it needs a scope. So how last semester many students used discovery kit. So do you have discovery? Who doesn't have discovery kit here?
My partner does though.
So you don't have.
I don't, but he does.
Okay. No, at least okay. So the problem, I will try to bring some scopes. Okay, 3 or 4. But I'm expecting that you should bring your discovery book, at least in the group. One of the groups should bring one, and you use it to see the signal. Is that okay? In case there is no way to see the signal, what I did, I posted 2 labs here. One lab, the other one, you generate the same signal, but I increased the time so that you can see it on the LED, right? So you can see the LED it's only for 1 second, or for 4 seconds, and so on, right? But anyway, I prefer, or I like to see you using the scope so that you can see the signal by yourself on the pins. Okay. Another important thing I have to say here, you have your scope should have, or discovery kit, it should have here two terminals. One is ground. Okay, the Dragon board, for the Dragon board, you have here, I'm gonna show you where. Yeah, here. Can you see here? Yes. So all you can see here, all the bits are here, right? So you can connect it here. So we have here, you can see all the pins are here. So you can just connect it here. However, also you should connect the ground of the scope to the ground of the board. So on the board you can see in several places, you can see the ground. So for example, you can see a ground here, in several places actually, yeah, you can see a ground here. So you should connect the ground of the scope to the ground of the board, and then you connect the other terminal to the port you want to see. You should see the signal. Okay, guys? Anyway. The second part of the lab will be also related to this program, just a little modification to this program. Okay, you should also see this signal. Any questions? Okay, now I'm gonna do something. I'm gonna do fun now. Okay, so this chapter is interesting. Okay, so let's do the buzzer here. It's interesting. So let me tell you again, as I told you, in this chapter, for every input-output device, I'm going to tell you how it is connected, right? Number 2, I'm going to explain how can we use it, right? And so here, let me explain this one. So I'm not going to follow the same structure. I'm not going to follow the flow of these slides. I'm going to explain everything, but I want to teach what we need for labs first. So here, okay. Here we have a buzzer here on. So I am done with the LEDs, guys. Okay, I'm done with LEDs. Now I'm gonna explain this one. You can see this one here. Okay, this one is a buzzer. It can make some sound. You can make some sound this one. By the way, if there is a sticker like this one, you can remove it, because with this sticker, maybe it's very hard to hear it. Yeah, so just remove it. So I'm going to explain how it is connected, how can we program it. Okay, very interesting. And you will see programming wise, nothing is new. Just I'm going to explain it. You will see by yourself, nothing is new here. Okay, anyway, so the buzzer, as you see here in this picture, the buzzer is connected to BT5. BT5, right? It's only one pin connected to the buzzer. Okay, BT5, port T, pin number 5. Okay, this is how the people designed the board to connect it this way. Okay, anyway, so now this is how it is connected. That means I don't need to say it, but I'm gonna just say it again. I don't need to say it. Look, before use the buzzer, you have to configure this port as output. You have to, right? Because this is output port, output. You're gonna write to it, so it has to be output. Okay. So how can you? So now the question: how can you generate a sound? If you want to generate some sound, okay. So all what you have to do is you have to just generate a square wave here. That's it. Yes. And I already told how can you generate a square wave, right? Yes, but you have the frequency of this square wave. You know, we can hear some frequencies, right? Our ears can hear some frequencies. Usually it is between 20 hertz to 20k hertz. Okay, not everybody is the same. Also, age edge is also important. So children can hear more frequencies than younger people or old people. Okay. So anyway, somehow interesting. So I have, in order to make some sound, I have to generate the frequency of this square wave. It has to be in this range. Okay. One more thing. By changing the frequency, you can have different tunes. You know what I mean by tune, right? Tunes. So that's why some students were able to use it to generate some music, right? But for sure, the quality is not great because it's just a very simple device. You get what I'm saying? In practical application, very cheap, very simple device, right? In practical application, when you write, for example, when you write the pin code and the pin code is wrong, so you want to notify the user, so you generate something like that just to notify the user. So it should be used for something simple like this one. You got what I'm saying? When you open a door using your Eagle card and the door opens, also it gives you some signal, right? If something is wrong, it can give you alarm, alarm like this one. And that's what we're going to do now. I'm going to show you a program to do this alarm, right? So this is so let's look at the programming. How can you program it? Very trivial. Number one, it's just one pin. You have to configure this pin output. This is number one. Number two, you have to generate a square wave. That's it. I already explained how can you generate a square wave. Okay, output 1, wait some time, output 0, wait some time, and repeat. That's it. You got what I'm saying? So now I'm going to explain how can you generate like alarm or two-tone siren or alarm, something like police alarm, something like that. Okay. So what I'm going to do, I'm going to generate 250 hertz for some time, and then I'm going to alternate. So I'm going to move to 500 hertz for some time, and then I go back. So this is how can we make an alarm? I have to alternate between two different frequencies. You got what I'm saying? That's why when you hear the alarm is two tones, right? So we alternate between the two tones to make alarm. Okay, that's exactly what we are going to do right now. So in the example, in the program I'm going to explain now, I want to run everyone. So this tone for half a second, and then I want to run this one for half a second, and then I want to repeat. Alternate. Okay, so I'm going to show you how can we do it. Any question? Okay, guys. Okay, so let's see how can we do it. Here again, this is the program. I'm sure this program is working. We tested it. You can find it on the course website. Okay. So number one, you have, as I said, you have to configure BT5 as output. So you can say bit set DDRT, and then you have to put one here because I want to set this bit in order to configure this pin BT5 output. Is that okay? One time is enough. Okay. Now, my program is going to be here all the time. We're going to keep looping here all the time. This part should generate 500 hertz signal for half a second, and this part should generate 250 hertz signal for half a second. So half a second here, and then I'm going to go back repeat again. So from here to here, it's going to take 1 second, right? Half and half. Is that okay, guys? Okay. So let's explain how it works. Okay, very simple. Look here. Number one, how can you generate 500 hertz signal, right? You know the time from here to here, as you know, this time, this t, we call it period or interval, whatever you want to call it. So this interval should be 1 over f, right? So f is 500 hertz. So 1 over 500 should be 2 milliseconds, right? So that means this one should be 1 millisecond and this one should be 1 millisecond. Okay? So in order to generate a 500 hertz signal, so the delay here has to be 1 millisecond and the delay here also has to be 1 millisecond. Is that okay? I'm going to show you how it is very easy, very trivial, nothing is new. This is how it works. Number one, pull BT5 high. Okay? bit set PTT, please don't be still confused between DDRT, direction register, and port T, right? Direction is for direction, input or output, one time is enough, right? But this one is the port itself. And by writing to this one, you actually is gonna write on the pin, right? The hardware is gonna write to the pin. Anyway, so here, bit set, so I'm gonna pull BT5 high. As you see here, I have to pull it high. So this instruction will do that. We'll pull the pin high, okay? Then I have to wait 1 millisecond, right? Then I have, after 1 millisecond, I have to pull it low, right? And then I have to wait 1 millisecond. Is that okay, guys? So this instruction here should generate one cycle, right? One cycle. Is that okay? One cycle. Easy, right? Pretty easy. Okay, now the question is, I want to keep repeating it for half a second. So how I can do that? Because after half a second, I have to move to here, right? So how I can do that? I'm going to tell you how. Very easy. Look here. If one cycle takes 2 milliseconds, 2 milliseconds. Is that okay? So how many cycles I have to generate in half a second, right? How many cycles? It's gonna make half a second. So if you do the calculation, you find it should be 250. So 250 cycles should be half a second. So what I'm gonna do, I told you guys, this part from here to here is gonna generate one cycle. One cycle. Very easy. All what I'm gonna do, I'm gonna repeat this part, loop, I'm gonna repeat it 250 times. That's all, very easy, right? So that's what I did. So I'm gonna put this one in register X, and then I'm gonna repeat this part 250 times. So I'm gonna generate 250 cycles. 250 cycles are equivalent to half a second. Is that okay, guys? After that, I'm gonna move to here. Is that clear? So for half a second, I'm gonna generate 530 signal. Okay. Here, I'm gonna repeat the same thing again here. But look, programming, exactly same program. But I'm gonna change the numbers. Look how it changes the numbers. Number one, I wanna generate this time 250 hertz. Again, because it's 250, so the time from here to here, T should equal 1 over 250 hertz, which should equal 4 milliseconds. So the delay here has to be 2 milliseconds and 2 milliseconds in order to generate 250 hertz. Is that okay? So this is the first thing I did. So look here, guys. Output high, wait 2 milliseconds, low, wait 2 milliseconds. That's it. So this part is identical to this part. Identical. The only difference is I changed the delay from 1 millisecond to 2 milliseconds to generate different frequency. Okay, guys, any questions? Okay, now, very easy. Just to change the delay, you change the frequency. Very easy, right? But you have to select the correct delay to generate the frequency you want to generate, right? Anyway, then the question becomes, how many times I have to repeat it? How many cycles? Okay, again, I have similar to what I did before. Now, in half a second, okay, now every cycle is 4 milliseconds. Okay, for every cycle 4 milliseconds. So, how many cycles I have to generate in half a second? Okay, if you do the calculation, you will find I have to calculate 125, which makes sense. It has to be half of this one. Right, because the time here is double. So here in half a second I have. So what I did loop, as you see here, guys, I did loop. So here I'm gonna repeat this part. I'm gonna repeat this part 125 times. Is that okay? So half a second. That's why I'm gonna choose a video now But when you hear the video, you will hear two different tones, right? Any questions? Any questions? Okay, so I'm gonna show the video now. I'm gonna play the video before I explain how can you do the same thing in C, right? It's gonna be the same thing, but I'm gonna use C instruction, but it's gonna be the same thing. Okay, so here I run this one half a second and this one half a second. Also, what you will see in the video is I'm just playing. So you already have the board, you already have the program, you can run the program and you can play. You can see what's gonna happen when you play, right? So I'm gonna play. So what happens if I make it shorter? So for example, instead of half a second, let's make it shorter. Quarter a second. How the sound will look like? You understand what I'm saying? So that's what I'm gonna do in the video now, right now. So for example, if I cut this one in half, and I cut this one in half, like 61 or 62, something like that. Okay, it doesn't need to be very accurate. It's okay. Okay. So cut this one in half and half. What can you what will be the sound will look like? Okay. It's still you will hear alarm because it's two tones. Okay. But it's gonna be like urgent alarm. You know the difference between alarm and urgent alarm. When you hear something like so it's very quick, right? So it's like urgent alarm. You will see right now in the video. I want to show the video before we continue.
Here, the tone is 250. Here is 250.
250 and 125. So the same thing I explained.
This one is 125. Okay, sorry. Now let's make the tone shorter.
So I'm gonna make the time shorter.
For example, instead of 250, I'm gonna make it 100. And as shown here,
Try to
instead of
try to realize the difference. You will hear now.
So now you will see the difference.
Is that okay? This is the devices here. Anyway, fun, right? Very easy, fun. Nothing is new. And I told you, starting from chapter 3, 4, 5, I'm not gonna explain new programming instruction. I'm gonna just use what I took before to program different input-output devices and so on. So now I'm gonna explain how can you do the same thing in C language, and you will see no difference. I'm gonna use the C language instructions. Okay. So the first thing here. This is the C language program. Number one, you have to configure BT5 output, right? You have to do that by outputting one. You have to put one in TD, DDR, port T, right? So in bit number 5, you have to put one. And as I explained to you before, in order to put one, you have to use OR operation. That's what I did, okay? So one time is enough. Most of the time, your program is here. All the time it's here. Okay, so now this is the first part for 500 hertz, and this is the second part for 250, right? And then I'm going to repeat. Pretty easy, right? So look here, same thing as I did before, exactly same thing. So here I have to output. I'm going to output BT5 is equal to 1, right? So here I'm going to output 1. Then I'm going to wait 1 millisecond. Then I have to output 0, right? You have to output 0. When you output 0, guys, if you want to output 0. So how you came up with this number, DF? Okay, very easy. The bits you don't want to change, I have to put 1 because 1 is not going to change the bits, right? The bit you want to change, you have to put 0. So here, if you look at this one, I put 0 in bit number 5. Okay. Again, don't be confused. When I say bit 5, I mean I started from 0 to 7, right? So 5 is actually it's a bit number 6, but I don't want to confuse you. I'm calling them from 0 to 7. Anyway, so now, and then I'm gonna output 0, then I'm gonna wait 1 millisecond. So this instruction here, guys, from here to here, this instruction should generate one cycle of 500 hertz. Okay, how many times I have to repeat this part? Similar to what I did before. How many times? 125. That's what I did. So I made full loop 250. So I made full loop 250 times. So I have to repeat this part 250 times. Is that okay? Nothing is new, similar to what I did before. Okay? Same thing here. I'm going to generate one cycle. This cycle should be 250 hertz. Okay. The delay, if you look here, guys, this instruction is similar because this one is going to pull high. This one is going to pull low. They are similar. The only difference is this one is 1 millisecond. Now it's 2 milliseconds. 1 millisecond, 2 milliseconds. Is that okay? And then, so this one is going to make only one cycle. From here to here, it's going to make one cycle, right? So I'm going to repeat this cycle 125. This way. Okay, guys, any question? If you have any question, just raise your hand. And again, you have this program here. All the programs, you have it, okay? Any questions? Okay. Last time I forgot to tell you something very important, guys. Okay, listen to me. Now, in C language, I'm going to use some functions. In C language, I'm going to use functions, okay? So like MS delay, okay? So how can we define? So these functions are coming with Code Warrior. So when I create a new project, they already there. The answer is no. The answer is no. Okay. These functions, we made them. You can make one of these functions, right? And just use them. And more interestingly, these functions are written in assembly. So you can write some functions in assembly and you can use them in C language. Okay. Number one, why somehow it can be overcomplicated? So why do you need to do that? No, I'm not gonna ask in this course. I'm not gonna ask you to write function in C in assembly and call it in C. Okay. However, I put tutorial online. If you wanna see how we created this function, or just in case you wanna modify some of these functions, okay? So it's already there. But I'm not gonna ask you in exams or anything to create function assembly, call it from C. So let me tell you. Okay, so here, guys, this file, you can find it in the course website, this file here. Number one, in assembly, when you create a new project in assembly, okay, you select file, create a new project, and you can create a new project and use assembly, okay? But don't forget, in assembly, also I created a file, subroutine, as I explained last time. You need to include it in your program just to make it programming easy for you. So you don't need to copy subroutine and paste them. You don't need to do that. Just include the file and then you can use all the subroutines after that. You get what I'm saying? In assembly, the story, again, in assembly, you can create a new project and then you include the subroutine file and then you can use all the functions I'm going to teach. in this chapter and next chapter. Okay, but for C language, it's a little bit different. Okay, so that's why when you run a C language program, okay, I post on the course website a project. You can open this project and just use it. Don't create a new project. Why you shouldn't create a new project? Because if you create a new project, the new project does not have the functions, the C function you are going to use, right? So always, I'm explaining here, I already created a project and I put all the function in this project. So for C language, you have to use this project. It's on the course website. So what you have to do, guys, is number one, this is the project. I put it in the course website. All what you have to do is, again, in C language, don't create a new project. C language is different from assembly. Just use the project I give you because all the functions are defined here. I'm going to show you how the functions are defined here. I'm going to show how these functions are written in assembly, and I'm going to call it from C, okay? So that maybe in the future you need to modify this function, maybe, or you can create, if you want, you can create your own function, write them in assembly, call them in C. So anyway, so all what you have to do in C is you have this project, you have to download it from the course website. That's number one. Number two, you have to open this project this way. After you open it, so now I opened the project. Once you open the project, you will see some programs there, right? So all what you can do, just remove this one and then write your program here, okay? But you have to keep the first lines here, okay? As I said in the lecture, okay? So just delete this one and put your program here, and it's gonna work. Again, I'm doing that because all the functions are defined here. Otherwise, CodeWorker is gonna tell you what this function is. I don't know what this function is, but it's not defined. It's not coming with CodeWorker, okay? After that, that's what you are gonna do all the time, and that should be fair enough, okay? However, if you wanna learn more, okay, here I'm explaining how I created the function in assembly and how I called it in C, so that you can create your own function or you can modify one of the functions we have if you need. Okay? So I'm explaining here in this tutorial. Again, I'm not going to teach it because somehow I want to focus on C language. I'm not going to ask in this. Okay. So for example, here you will find in this file. If you open this file, you will find all the functions are defined here. So I'm explaining now. I want to create a new function. Okay. So I'm explaining if you want to create a new function, how can you do it? So here you have to write. You have to define it here in this file, right? Main.asm, okay, and then you have also main.asm.h, okay. You will, if you open the project, you will see all the functions we are using are here. So far, I explained only MS delay and to turn on and off the LED. I'm going to teach you more, but all of them are here, okay. And then once you do that, you can write the content of the function here. So you have to declare the function here. You define it here. This is the name of the function. These are the arguments it receives, and this is what it's going to return. And then you can write the content here. You can see the content is written in assembly, right? And you can call it. You can use it in C. That's what I did. So here in this tutorial, I already did one function. I wrote here the assembly code, and then here I'm calling it for main.c. Your program has to be in main.c and should work after. Okay. Anyway, any questions? Is that clear? Let me summarize what I said in one sentence. Okay, guys. Number one, in the coming lab for assembly, what should you do? Nothing is new, similar to what you did before. New project, right? There is only one difference. Okay, you need to include the subroutine file. Otherwise, if you don't do that, every time you use one function, you have to copy, paste. I'm just making it easy for you. Okay, that's number one. Number two, C is different. For C, you already have a project online. You have to use this project, okay, because all the functions are defined there. Okay. Once you open this project, as I explained here, there is a file called. Yeah. So once you open it, you will see there is a file main.c, right? This is where you have to write your program, right? So you can write your program here. For sure, you have to keep the first lines. It's include files here, as I explained. This is a file, even we include this is the same file we include in assembly. This function, you are telling C language what is the this is the number of our microcontroller. So because it can be used for different numbers. So you have to tell which number exactly. So always you need to keep this one. And then you can remove this part here in the main, you can write your own code. Okay. Any questions? Okay. Now I'm gonna move to, so now I explain how can you use LEDs, right? This is output device. I explained also how can you use the buzzer. Also, this is output device, right? Now I'm gonna explain input device, which is the switches, right? So I'm gonna explain how can we program it. Okay, so if you look at the board here, look here, guys. We have here switches here, switches, right? Okay, so we have 8 switches here, 8 switches, right? Little switches. Okay, so every switch can be on or off. Every switch here can be on or off, right? So and so all what you need to know in your program is the switch is connected or not. If the switch is connected, that means the user want to do something, you can do it. If the switch is not connected, that means the user want to do something else, you can do it, right? So you need to check. You need to check the status of the switch. Is that connected or not, right? So first of all, this is connected to port H. This is connected to port H, okay? And the way it is designed, as you will see right now, is if this is port H, this is PTH. If this is port H, the way it is designed, as you will see right now, is this is the pin, right? PT0, for example, or PH0, okay? The way it is designed, if the switch is connected, so I have a circuit here, it's gonna put 0 volt here, right? And if the switch is open, so I can have 5 volt here. So I have a small circuit. This small circuit is gonna put 0 volt or 5 volt. Is that okay? So if you want, you will see the small circuit. It's very small circuit. You will see it right now. Okay. So now, if you want to know if the switch is connected or not, or what do you need to do? I just want to check if there is 0 volt or 5 volt. If there is 0 volt, that means the switch is connected. If there is 5 volt, that means the switch is open. That's all what you have to do, just to check. So how can you check? How can you do that? Very simple. As I said before, here we have the port BTH. So BTH is the register, data register for port H, right? The data register, BTH. As I told you, every pin is connected using hardware to 1 bit here. Every time there is 0 volt, so there should be 0 logic 0 here, right? If there is 5 volt, so there is logic 1 here, right? You don't need to do this update. The hardware is going to do that, right? So all what you have to do is very easy, very simple. All what you have to do is you have to look at the byte BTH. That's it. So you have to check. If you want to know the status of this switch number 7, for example, you have to check this bit. That's it. You have to check this bit. Is it 0 or 1? If it is 0, that means the switch is connected to this 1. That means the switch is disconnected. Very easy, right? How can you check 1 bit? Okay, very easy. I explained in assembly. You can use branch if clear. You can use branch except, as I explained before, or you can use AND operation also, as I explained before. So you can use AND operations. You can put here 1, right, and you can put 0 everywhere. As I did, even I did the same thing right now. Okay, so here you're gonna get bit 7. And then 0, 0, 0, 0, 0. Okay? If the result is 0, that means this bit is 0, otherwise it is 1. That's how can you check. This is what you have to do in C. Also, you can do the same thing in also in assembly, right? But we have only one option in C using logic AND. But in assembly, you can use branch set as I explained before. Anyway, so that's it. So that's what I'm gonna do right now. So let me tell you how the circuit looks like here, and how this circuit is gonna put 0 or 5 if the switch is open or closed. Okay. So here, this is how the circuit is. Forget this part for now. So forget this part. I'm gonna talk about it later. So forget it. So this is how the circuit looks like, guys. So you have here resistance, big resistance, okay, and then you have a switch here. Here you have 5 volt, and then you have here very small resistance, so it's almost short circuit this way, okay? And then I'm gonna take this one, I'm gonna connect it to the pin, right? So if you see now, if the switch is open, there is a very small current here, very small current, okay? Almost there is no current, so the voltage here will be close to 5 volts. Is that okay? So the pin should have 5 volts if you open the switch, okay? Now, if you close the switch this way, so now there is a current this way, right? And now the voltage here will be 0, so you are gonna apply 0 voltage. Is that okay? That's what I said. What I said. This is the external circuit I told you about. So if the switch is open, so the pin is gonna have 5 volts. That's why if you read the bit corresponding to this bit, you will find 1, logic 1, right? Here, if it is 0 volt, if you read that data register for port H, you will see logic 0. Okay, any questions? Very easy, right? Again, all these connections are done, you cannot see it because it's done in the board. Okay, the connections are done in the board. However, if you want to do, if you are gonna do your own project, you have to connect it. So you have to connect this circuit, right? Anyway, so let's talk about programming. How can you program it? Very easy. Again, I'm gonna use 2 registers. One register is a data direction register, right? But this time, this one is used to configure port H, but this time you have to put 0 to configure it input. All what we did before, we used to write once to make it output, but this time you have to write 0 to make it input. So you have to do this configuration, okay? One time is enough. Once you do it one time, it's okay. And then every time you want to read port H, you can just use PTH. That's it. So you can read PTH, right? Or you can use branch of clear, branch of set, whatever. Okay. So I'm going to show you now a program here. Let's see what I want to do here in this program. What I want to do here in this program is I want to read the switches. I want to echo the status of the switches on the LEDs. What this means? It means if the switch is open, so every switch should have a corresponding LED. If the switch is open, so its LED should be off, right? If the switch is closed, LED should be on. That's what I want to do. You get what I'm saying? Just so here in this program, I want to use both LEDs and the switches. Okay, at any time you connect the switch, the corresponding LED is going to be on. Is that okay? So let me show the video first before I show you how I did the programming.
So we get here this program.
So now all the switches are open, that's why all the switches are off, right? So this switch should control this LED. If I turn this one on, so this one should be on, right? So you'll see right
Now all the switches are off. That's why all the lids are off. When I turn one button on, so what happened to the associated lid? It's on now. Let me try to do all of them. all the leads are on, and so on. So if you any switch off,
Yeah, because I'm gonna make the program continuous. I'm gonna check continuous, not only one time, continuous, right? That's why at any time you change the status of the switches, LED is gonna change. You will see right now how I did it. Okay, it's very easy. You will see. So how I can do it? Very simple. Look here. Where are the LEDs? They are in port B, right? Where are the switches? They are in port H. So all what I have to do, I'm gonna copy port H, put it in port B. That's it. Copy port H, put it in port B. You got what I'm saying? So I'm gonna read port H, and then I'm gonna send it to port B. That's it. So continuous is this way, right? But there is a little problem here. What is the little problem? Look, if the switch is open, I'm gonna get 5 volts, right? As I said. And if you get 5 volts, if you send 5 volts to port B, you are gonna turn the LED on. So open is gonna turn on. Closed, you wanna turn off, right? So you're gonna turn the LED off. This is not the logic I wanna do. It's against the logic. The logic is if it's connected, LED is on, right? So what should I do? Very easy. All what I have to do, I'm gonna read port H, I'm gonna flip the bits, and then I'm gonna send them to port B. So that if the switch is connected, I'm gonna get 0, the 0 flip it to 1, and then I send it to the LED to turn the LED on, to have the same logic. Okay, that's it. So let's see how I did it here in the programming. Okay, so again, here, this part is configuration. Now I have to configure many things, right? So now you have to configure port H, right? Because I'm using port H switches. Also, you have to configure port B because I'm using LEDs. Also, I told you if you want to use LEDs, you have to program port J because this is the enable for LEDs, right? And also you have to write some value for port J to enable LEDs. Also, you have to configure port P, as I'm going to explain later. Port P is used to enable or disable certain signal, right? So anyway, nothing is new here. All of this part is just a configuration. One time, I'm okay, I'm happy. One time, everything is set. So you already set the circuit, right? Now, the program is going to be here all the time. It's going to be here, okay? So what I'm going to do, I'm going to read port H. I'm going to say load register A BTH. I'm confused. This is difficult. What this means? What's BTH load? We didn't do that before. No, we did. We did. You remember? We did before load 1000, right? That's what we did before. This is similar to this one. No difference. Okay? As I said before. So no difference. This one is exactly similar to this one because, as I told you before, BTH is defined in the file with a certain number because every port should have addresses like memory, right? But to make it easy for you, instead of writing numbers, you are going to write English words like BTH, okay? And then they are going to change to numbers because they are defined in the file, as I said before. So don't be confused. Every time you see BTH or DDRH or all this register, this is similar to 1000. So don't be confused. This is like 1000, right? So we did something like before. So what I'm going to do here, I'm going to read a byte. I'm going to read a byte from BTH, right? So this byte should tell me the status of the switches, right? So I have a byte. Now I put it in register A. Every bit, if a bit is 0, that means the corresponding switch is connected. If a bit is 1, so that means the corresponding switch is open, and so on. Okay. Anyway, so I'm gonna read BTH. I'm gonna complement A because I want to flip the bits as I told you, and then I'm gonna store A in port B. Very easy. Again, don't be confused. Port B is like you store in 1000. It's exactly the same thing, right? But here port, right? But be careful here. There is a small trick here. Be careful. 1000. You can read from 1000, you can write to 1000, right? Memory location, you can read or write. However, for ports, either you read or you write, because the port is either input or output, right? It cannot be the same, right? That's why you will see always port H, we read from port H. Port B is output, so always we write to port B, okay? There's a small difference between memory location and this, okay? Anyway, so then I'm gonna keep looping. So I'm gonna keep looping. Always I'm gonna read port H, complemented, sent to port B. Okay, guys? Any questions? So how can we do the same thing in assembly? Sorry, in C. Again, in C, as you see here, number one, if you like functions, you can use these two functions as I explained before to enable AEDs and disable 7 segment. Also, these two functions are going to do some configuration for output ports, okay? And then for port H, you have to put this one for port H, right? So this part is configuration, nothing is new. This part is just similar to this part. But here I'm using assembly, here I'm using C, right? So it's similar to this one. Now, this is infinite loop. We're going to keep looping here forever. So what I'm going to do here, number one, you can do this way. I can say port B is equal complement of PTH. I told you this symbol means complement, right? So I'm going to read here, I'm going to read the value on port H, okay? I'm going to complement this value and then I'm going to store it in port B. You can do this way if you want, it's okay. The other way you can do it using functions. I told you, or here we have a function. This function is called LEDs on. What this function is doing, whatever you write here is going to write it to port B. Okay, so this is what this function is doing. So whatever you send argument here to this function is going to put it on port B. Okay. By the way, in C language, as I told you, I'm going to teach a number of functions. And on the course website, I made a summary to all these functions. So I put all of them in the course website. You'll find the files that has a summary of description to all these functions. Okay. Any questions? Okay. Let me teach one more program. It's easy. Nothing is new. I want to make sure you understand how can you use the switches. Right. Very easy. Look here. This is the police siren program. The same program I taught right now. The police siren. The police siren. Okay. But I want to modify this program. So that I want to add a switch to the program. Right? So that if I connect the switch, you turn the alarm on. You can hear the alarm. It's gonna work, right? If you turn the switch off, no alarm, right? So it's like turn on and off for the system. Okay, if you want to call it a system, okay. So I have a small system is doing alarm, right? And then I'm gonna use a switch as on and off, right? So this switch can connect. Alarm is on, alarm is off. Okay. Look how I'm gonna do it. Very simple, very simple way. Look here. If just one line, if I remove this line, this is the program I taught before. This is exactly what I taught before. This is half a second, nothing is new. Half a second, and this is half a second, and then you go back to here. Right? So this is the same program. I'm gonna just add one line, okay, to turn it on and off. Look how I'm gonna do. Look here, guys. So here, branch if clear this bit. So I'm going to check this bit. If this bit is connected, is clear. So connected means here maybe I'm using opposite of the logic, but that's okay. So connected here means off. You can, so if you don't like it, you can use set here. It's not a big deal. Okay. So here, if it's clear means that if the switch is connected, right? That means I'm going to consider connected means off. The system should be off. You know. So if you connect the switch, so if it is clear, so I'm going to check this bit. If this bit is clear, I'm going to loop here. So I'm going to keep looping here. So I'm not going to come here. So that's why you're not going to hear anything. Very interesting. So again, look as I did. Now, I'm gonna look very simple. I'm gonna look at this switch, right? If this switch is open, right? So it's not clear. So I'm gonna come this way for 1 second, and then after 1 second, I'm gonna come here to check again. If it's still the system, if it is still set, if this bit is set, okay, that means the switch is open. I'm gonna come here again. After 1 second, I'm gonna come here back to check, right? Okay. Now, if it is set, if this bit is set, if I connect the switch and now it is set, so I'm not gonna come here. So the branch is gonna take me here. I'm gonna continue here. I'm gonna continue here. I'm gonna continue looping this way until you change the switch. Okay. So if you look here how the program works, actually here, I'm going to show the video, and you have to notice something. You have to notice something. Okay, look here. If the alarm is working, so I'm going to check every 1 second, right? Because I'm going to come here for 1 second and then go back to check. Come here and then go back to check. So I'm going to check every 1 second, right? That's why there may be some little delay. That's what you should notice. It's just a little because it's just 1 second, right? But there is a little delay. So once you connect the switch, for example, because I'm going to check every 1 second. So I'm going to check here, I'm going to check here. So if I change the state of the switch here, so it's going to continue, the alarm is going to continue until 1 second, until you come here to check again, right? So you will see if there is alarm and I want to turn the alarm off, you will see in the video that sometimes there is a very little delay. This delay is just a part of a second. So okay, it's a portion of second. So it's less than a second. Got them? So sometimes you don't notice it, but you will notice it in the video. Okay. However, if the system is off, I'm keeping looping here. If it's off and I'm looping here, right? There is no delay because once you connect it, you are gonna come here right away. You know what I'm saying? So you will see right now in the video, if there is no alarm and you turn the alarm on, it's gonna be on right away. But if the alarm is on and you want to turn it off, there may be some little delay. Okay. Anyway, let's see the video.
So let's run this program. Okay, the siren is working. Now it's off. So here I'm going to use the first button as on-off button. Look.
You can
sometimes there is
little
very delay
it was not
because we check the status of the switch every 1 second.
It's not a big deal anyway. So
sometimes if I turn it on off quickly, you can see some delay.
Again, in this application, if you have a delay less than a second, it should be okay, right? But maybe in other application, this delay is a problem, right? So you have to use a different way, like interrupt another way. You know what I'm saying? Anyway, so let me see if I finish it. That's enough for me. Okay, I wanna teach RGB. It's very interesting, but should I teach it? It should take 3 minutes or 4. If you want to take rest, I'm okay. Okay. Take a rest. Okay. So we're gonna start the test 6 o'clock. Okay. Again, guys, don't forget next time to bring your discovery kit.